Assalamu alaikum. Welcome to lecture number 15 of the course on statistics and probability. Students, you will recall that in lecture number 3, I began with you the discussion of the various ways of summarizing and describing data. And for the most part, our discussion pertained to the analysis of a univariate situation. That is, we talked about the central tendency, the dispersion, the skewness, and the kurtosis of one single variable. But students, I'm sure that you will agree that in many situations, our interest is not in just one single variable, but we are interested in studying situations where a number of variables are related with each other. For example, if you consider the case of the yield of a crop, you will agree that the yield depends on so many factors: the fertility of the soil, the amount of rainfall, the quantity of the fertilizer used, and other variables. So, इस हवाले से आज हम जिस मौजू पे डिस्कशन करेंगे, that is regression and correlation, a very important area of statistics, and we will be discussing the simplest situation, that of simple linear regression and correlation, where we develop and establish the relationship between two variables only. All right, let us begin this interesting topic by picking up an example. An important concern for any pharmaceutical company producing drugs is to determine how a particular drug will affect one's perception or general awareness. Suppose one such company wants to establish a relationship between the percentage of a particular drug in the bloodstream and the length of time it takes to respond to a stimulus. जैसा कि आप जानते हैं, कई दवाइयाँ ऐसी होती हैं कि जिनके कुछ साइड इफ़ेक्ट्स होते हैं. तो यहाँ पे कुछ ऐसी किसी दवाई का जिक्र हो रहा है जिसकी वजह से कुछ ड्राउजीनेस सी क्रिएट हो जाए, और इसको ये स्टडी बड़े इंटरेस्टिंग तरीके से कर रहे हैं कि फॉर एग्जांपल अगर आप उसको प्रिक करें, उसको सुई चुभोएं, तो कितना टाइम लगता है टू रिस्पॉन्ड टू दिस प्रिक. और इसीलिए जैसा कि अब आप देखेंगे स्क्रीन पे, जो डेटा है रिगार्डिंग द रिएक्शन टाइम, दैट इज इन मिली seconds. Suppose that the company administers this drug on 5 particular patients and obtains the following information. Subject A, B, C, D, and E, percentage of drug in the bloodstream 1%, 2%, 3%, 4%, and 5%. और इसके अगेंस्ट जो रिएक्शन टाइम है टू रिस्पॉन्ड टू अ पर्टिकुलर स्टिमुलस, दैट इज 1, 1, 2, 2, and 4 milliseconds. Students, as you will agree, in this example, the reaction time is that variable which depends on the variable percentage of drug in the bloodstream. So, we say that reaction time is the dependent variable and we denote it by Y, and percentage of drug in the bloodstream is the independent variable and we denote it by X. In order to determine the nature of the relationship between the dependent variable Y and the independent variable X, students, the very first step is to draw the scatter diagram. अब scatter diagram से मेरी क्या मुराद है? It's a very simple diagram. You take the independent variable X along the x-axis and the dependent variable Y along the y-axis, and you simply plot all those ordered pairs that you have in the form of points on the graph paper. So, going back to the example that I just discussed, the scatter diagram will be of the form that you now see on the screen. The point to understand is that for the subject A, the ordered pair x comma y is equal to 1 comma 1. And hence, our first point on the graph paper will have abscissa equal to 1 and ordinate also equal to 1. For subject B, the ordered pair and the point is 2, 1. For subject C, it is 3, 2. For subject D, we have 4, 2. And last but not the least, for subject E, the point is 5, 4. Students, the scatter diagram is a very, very useful tool to judge the nature of the relationship between x and y. अभी जो diagram आपने देखा, उसमें आपने ये note किया होगा that there is an upward trend. And what do I mean by upward trend? It means that as x increases, y also increases. And this is exactly what you just saw. Of course, you will say that the points were up and down, but if you look carefully, you can see a linear trend in this data. And in the figure that you now see on the screen, this fact is depicted. Students, why is it that all those points that you saw on the graph, they are not all lying on the straight line? This is a very, very fundamental point, and you must realize that in the sociological sciences, psychology, sociology, economics, and many other social sciences, you will 95 or 99% of the time not have an exact linear relationship. But you will be able to judge that overall your data follows a linear pattern. Sometimes it will be linear, many times it will be linear, and sometimes it may be parabolic, it may be like a curve, and sometimes you will have some other patterns. But this point, why is it that the points are not all lying on that mathematical curve or line? I would like to explain this to you with the help of an example. Consider the case of a few firms who are spending a certain amount on research and development, R&D. अगर आप इन firms का data लें of R&D and the profit margin, and if the R&D expenditure is exactly the same, you will find that still the profit margin will be different. इसकी वजह क्या है? इसकी वजह ये है कि these firms are operating under different conditions. The efficiency of the firm, the goods being produced in the market, the firm's share in the market, all these things affect the profit margin of the firm. So, although the R&D expenditure was exactly the same for these few firms, their profit margins are different. So, this is exactly the point that I was conveying earlier. For one single value of x, you will have different values of y. अगर आपका x जो है वो आप खुद फिक्स कर रहे हैं, even then the y variable is a random variable. और ये जो बात मैंने आपसे आखिर में कही, this points to a very important mathematical point with reference to regression analysis, and that is that your x variable should be a non-random variable, whereas your y variable will be a random variable. आइए उसी एग्जाम्पल पे वापस चलते हैं जिसका स्कैटर डायग्राम आपने थोड़ी देर पहले स्क्रीन पे देखा. स्टूडेंट्स, अगर हम ये कह रहे हैं कि दिस diagram follows an overall linear pattern, then obviously our objective will be to find the equation of this line that passes through this diagram. I'm sure that all of you know the basic equation for a straight line, and that is y is equal to mx plus c, where m represents the slope of the line and c represents the y-intercept. If we rename the values c and m as a and b, the equation becomes y is equal to a plus bx. By the slope of the line, we mean the tangent of the angle theta, where theta is the angle between the line and the horizontal axis. And by the y-intercept, we mean the distance between the origin and the point where my line intersects the y-axis. Students, अब एक बहुत ही important बात देखने की है, और वो ये है कि through the same scatter diagram, we can have many lines. As you now see on the screen, for the one scatter diagram which had only 5 points in the example that we considered in the beginning, you can have 1, 2, 3, and many lines passing through it, and all of them are more or less reflecting the linear relationship that exists between x and y. तो फिर सवाल ये पैदा होता है कि हम इनमें से कौन सी लाइन को सिलेक्ट करें as the one which best represents this particular data set. Students, for this purpose, we use a method called the method of least squares. And the line that we will obtain by this method will be called the regression line of y on x. And this entire procedure will be called simple linear regression. अब ये method of least squares से क्या मुराद है? इस सिलसिले में the first thing to note is that we would like to draw a line which is passing through the points, यानी कुछ points line के ऊपर हों, कुछ points line से नीचे हों. It should be a kind of an average line. तभी हमें intuitively ये महसूस होगा कि as if this is a good representative of this data. इस point को उन distances के हवाले से देखिए जो exist करेंगे between any individual data point and the line. As you now see on the screen, some points are above the line and some below, and you have vertical distances between all these points and the corresponding points on the line. The important point is that if my line is passing through the point x bar comma y bar, that is, if my line is passing through the mean point of the data, then the sum of the positive and negative deviations will come out to be 0. But the problem is that, as I indicated earlier, there can be many lines for which the sum of the deviations of the actual y values and the corresponding y values obtained from the line is 0. So, ये criterion काफ़ी नहीं है इस बात के लिए कि हम कौन सी लाइन पिक करें. ऐसी तो कई लाइनें हैं जो सबकी सब x बार y बार के थ्रू पास कर रही हैं और उनके एंगल थोड़ा थोड़ा मुख्तलिफ हैं, लेकिन वो सब इस क्राइटेरियन को मीट कर रही हैं that the sum of the deviations of the observations from the fitted line is 0. So, we need another criterion to get the best fitting line. And as I said earlier, this is the method of least squares. What we do is that we square each and every one of these deviations before we find their sum. And students, what we find is that the sum of the squares of the deviations of the actual data points from the line, that will be minimum for one particular line, and that line is called the best fitting line. ये बात आप अब स्क्रीन पर जो डायग्राम्स देखेंगे उससे वाज़ेह हो जाएगी. In the first diagram, you note that for the 4 points A, B, C and D of the scatter diagram, the line that passes through them in the direction that you now see generates 2 squares which are quite large, whereas 2 are not that large. But when we find the sum of these 4 squares, obviously that will be quite a large quantity. Now, if I rotate the line around the point x bar comma y bar, I get a new position, and in this new position, students, you find that the areas of the squares are not as large as before. Students, इस explanation से आप पे ये वाज़ेह हो गया होगा कि अगरचे पॉइंट्स A, B, C और D exactly उसी जगह पर रहेंगे, but if you rotate your line, there will be one position where the sum of the squares will be minimum. And this is exactly the principle of least squares. तो अब सवाल ये पैदा होता है कि वो जो हमने रोटेट करना है कि जिसके ज़रिए वो पोजीशन आ जाए कि जहाँ पे वो स्क्वायर्स बहुत ही छोटे हो जाएं, यानी मिनिमम सम अचीव हो जाए, हाउ विल वी फाइंड exactly that particular angle? Students, इसके लिए of course we have to resort to mathematical techniques, and we will be taking the derivative of a certain quantity in order to achieve those particular equations that will yield this best fitting line. लेकिन इस course में I will not be discussing any of the derivations. I will simply give you those equations which are the result of these derivations, and as you now see on the screen, the 2 equations which enable you to obtain the best fitting line are sigma y is equal to NA plus B sigma x and sigma xy equal to A sigma x plus B sigma x square. Students, these 2 equations are called normal equations. But please remember कि यहाँ पे ये जो लफ्ज़ normal मैंने कहा, this has nothing to do with the normal distribution that I mentioned in an earlier lecture, or which I will mention in detail when we do continuous probability distributions. ये जो 2 normal equations हैं, इन्हें हम simultaneously solve करेंगे in order to find the values of A and B. And these are exactly the 2 values that you need in order to find, to determine your line, which is the best fitting line to your data. The point to understand is that in these 2 equations, the only 2 unknowns are A and B. बाकी तो सारी जो quantities हैं, they will be available to you. After all, when you have a set of bivariate data, you already have a column of x and a column of y, and you can multiply the x column with the y column to obtain the xy column, or you can square the x column to obtain the x square column. And once you have all these columns, you will be able to find sigma x, sigma y, sigma x square and sigma xy. So, in equationों में, the only 2 unknown quantities are A and B, and when we solve these equations simultaneously and obtain A and B, we will have determined that line which is the best fitting line to our data. Let us apply all these points to the same example that we were discussing earlier. As you see on the screen, the sum of the x column is 15, sigma y is equal to 10, sigma x square comes out to be 55, and sigma xy is equal to 37. Substituting these values in the two normal equations, we obtain 10 is equal to 5a plus 15b and 37 is equal to 15a plus 55b. You noticed that I wrote 5a because n is equal to 5. N represents the total number of ordered pairs that you have. And in this particular example, as you know, we were talking about 5 patients on whom we had administered various percentages of the drug. Solving the two equations simultaneously, B comes out to be 0.7 and A is equal to minus 0.1. Hence, our equation of our best fitting line comes out to be y hat is equal to minus 0.1 plus 0.7x. आपने note किया that a hat has been placed on top of the y, and students, this is to differentiate between the actual y values pertaining to your data points and the y values that you obtain from the line corresponding to exactly the same x value. चलिए, line तो हमने fit कर ली. But I am sure that you must be thinking, what is the purpose of fitting this line and going through all these lengthy calculations? Students, this line plays a very important role in estimation and prediction. For example, in this example that we are just considering, suppose that we are interested in determining what will be the reaction time of a patient who has 4.33% of the drug in his bloodstream. जो हमारा original data है, वो तो 1, 2, 3, 4 and 5% के against हमें information दे रहा है. लेकिन हम अब interested हैं कि ये पता करें कि अगर 4.33% ड्रग हो उसकी ब्लड स्ट्रीम में, फिर उसका reaction time to the stimulus कितना होगा. As you now see on the screen, all we have to do is to put x equal to 4.33 in our equation of the line, and doing so, y hat comes out to be 2.931. So, you have noticed that through this process of regression, we have been able to estimate that a patient having 4.33% of a particular drug in his bloodstream will take 2.9 milliseconds to react to that particular stimulus. Students, इस पूरे regression analysis के अंदर और इस estimation procedure में जो मैंने अभी आपके साथ share किया, एक point बड़ा important है, और वो ये है कि one should be careful in the estimation process that your x value corresponding to which you want to find the estimated y value, that x value should be within the range of the x values which are available to you. In the example that we are considering at this point, आप जानते हैं कि x values जो available हैं वो हैं 1, 2, 3, 4 and 5. अगर मैंने 4.33 के लिए y estimate करना है तो that is all right. अगर मैं 5.5x के against y estimate कर लूँ तो वो भी काबिले कबूल होगा. But students, if I estimate y corresponding to x equal to 10 in this example, that will not be very wise. वजह क्या है? वजह ये कि 10 is so far away from the highest x value that is available to me that there is no guarantee that the linear pattern that we have established in this example for the values 1 to 5, that same pattern will prevail all the way up to x equal to 10. As you now see on the screen, it is possible that it becomes a curve rather than a straight line, and if you use the equation of the straight line to estimate the y value for an x value which is considerably far from the available x values, then your estimated value may be quite incorrect. All right, now that you have understood the basic technique of regression, students, I want to draw your attention to another point. अभी तक हमने जितनी discussion की, we assumed that y is the dependent variable and x is the independent variable. यानी जब हम y को estimate करना चाहें from x, then we will be applying the equations that you just saw. But in some situations, we may be interested in estimating the x variable from y. और आप ये सोच सकते हैं कि इसी equation को हम utilize कर लेंगे to find x corresponding to any particular value of y. क्योंकि आप x को इस side पे ले आइए, y को इस side पे ले आइए, and you can find an equation so that you have x is equal to something in terms of y. उसके अंदर y की value put करें और x आ जाएगा. But students, this is not the thing to go for, and the very important point is that if you want to regress, if you want to estimate x from y, then you should regress x on y. And in this situation, you will interchange the roles of x and y in your normal equations. I would like to encourage you to work on this problem on your own and to practice with one or two problems numerically. Students, at this point, I would like to discuss with you another important concept, and that is the concept of the standard error of estimate. Now, the point is that we have fitted a line and some points are above the line and some points are below the line. So, हम इस बात में भी तो interested हैं ना कि what is the degree to which they are scattering from the line? क्या हमारे points line के बहुत नज़दीक हैं या they are scattering away from it? And to measure this, we would like to compute what is called the standard deviation of regression or the standard error of estimate. As you now see on the screen, the standard error of estimate is defined as the positive square root of sigma y minus y hat whole square divided by n minus 2, where y denotes an observed value and y hat denotes the corresponding value obtained from the least squares line. Students, इस फॉर्मूले के स्ट्रक्चर से आपने रिकग्नाइज कर लिया होगा कि यहाँ भी बेसिक कॉन्सेप्ट वही स्टैंडर्ड डिविएशन वाला कॉन्सेप्ट है. वी आर summing the squares of the deviations of the y values from the estimated y values, the ones that we obtain from the line. Lekin, this formula is a bit cumbersome to apply, because in order to apply this, first we will have to find all the y hat values corresponding to all the x values that are available to us, and that will be a bit cumbersome. So, as you now see on the screen, the standard error of estimate denoted by sy dot x is equal to the square root of the quantity sigma y square minus a sigma y minus b sigma xy whole divided by n minus 2. ये जो notation है sy dot x, students, it is not very difficult to understand. If we are regressing y on x, we will write sy dot x, and if we are regressing x on y, we will write sx dot y. और आइए अब हम इस concept को apply करते हैं on the same example that we have been considering. As you now see on the screen, the column of y square has been added to the 4 columns that we already had, and the sum of the y square column is 26. the values of A and B have already been found, and now substituting all these quantities in the formula of sy dot x, the standard error of estimate for this particular problem comes out to be 0.61. अब सवाल ये पैदा होता है कि how will we interpret this value of sy dot x? The point here is, students, that sy dot x lies between 0 and sy, where sy represents the standard deviation of the y values. Now, if our sy dot x is close to 0, it means that those data points are not deviating very far from the line, that dispersion is less, and we can say that our line is a good representative of those data points. But if our sy dot x is large, and if it is close to the upper limit sy, then it means that the data points are deviating from the line, and the line is not very reliable for estimation purposes. In this example, sy, the ordinary standard deviation of our y values, comes out to be 1.10. And if we compare the sy dot x value 0.61 with the sy value 1.10, students, we find that 0.61 is not extremely small compared with this upper limit. And hence, we conclude that in this particular example, there is a certain amount of dispersion of the values around the line, and that dispersion is not extremely insignificant, and hence this line is not extremely reliable for estimation purposes. Regression के बारे में तो हमने बहुत डिटेल में बात की. The next concept, which is very important and closely related to the concept of regression, is the concept of correlation. As you now see on the screen, the correlation is a measure of the strength or the degree of the relationship that exists between two random variables. आपने नोट किया कि यहाँ मैंने कहा कि it is the strength of the relationship between two random variables. And this is a mathematical point that whereas in regression analysis, y is a random variable but x is a non-random variable, in correlation analysis, they are both random variables. For example, if you want to determine the strength of the relationship between the heights and weights of young children, you will realize that both height and weight will be regarded as random variables. Obviously, we would like to have a numerical formula to measure this strength of the relationship that exists between two variables. As you now see on the screen, the correlation coefficient is defined as covariance of x and y divided by the standard deviation of x into the standard deviation of y. Covariance of x and y is defined as sigma x minus x bar into y minus y bar over n, and it is a measure of the degree to which two variables vary together, and that is why we have the term covariance. The shortcut formula for the Pearson's coefficient of correlation is sigma xy minus sigma x sigma y over n, and this entire quantity divided by the square root of sigma x square minus sigma x whole square over n into sigma y square minus sigma y whole square over n. Let us apply this concept to an example. Suppose that the principal of a school is interested in ascertaining the correlation between marks in mathematics and marks in statistics, and he collects data for 9 students, and the marks in mathematics are 5, 12, 14, and so on, whereas the marks in statistics for the same students are 11, 16, 15, and so on. In order to compute the correlation coefficient, we construct the columns of x square, y square, and xy, and we obtain all the relevant sums, and substituting them in the formula for r, our answer comes out to be 0.88. To interpret this result, students, the first thing to understand is that r is a quantity that lies between -1 and 1. In case of a direct or positive correlation between two variables, r lies between 0 and 1. But in case of a negative or indirect correlation between two variables, it lies between 0 and -1. When I say indirect or negative relationship, I mean that as one variable increases, the other decreases. For example, as the temperature of the city rises, the sale of woolen sweaters declines. ऐसी situation में r will lie between 0 and -1, whereas in case of direct relationship, for example, as the temperature of the city rises, the sale of ice cream rises, so they are varying in the same direction. In such a situation, r will lie between 0 and 1. The stronger is the relationship between x and y. Graphically, the closer my points are to an upward going line, the closer my r will be to 1. So, in this example, if r is equal to 0.88 or approximately 0.9, students, you will appreciate that this means that indeed there is a very strong positive linear correlation between the marks in mathematics and the marks in statistics. इसी तरह अगर किसी और प्रॉब्लम में मेरा आंसर r equal to -0.9 या -0.8 होता, तो that would have meant that there is a very strong negative linear correlation between x and y. The closer my r is to 0, students, the weaker is the correlation between x and y. And if r is exactly equal to 0, that means that there is absolutely no correlation. Students, in today's lecture, I have discussed with you a few concepts concerning regression and correlation, and I have tried to convey to you the basic philosophy of this area. But believe me that we have done just the very beginning of a very vast and important area of statistics. I would like to encourage you to study this on your own and to go on to study not just simple correlation and regression, but a little bit about multiple correlation and regression, where we try to study the relationship between not just 2, but 3 or more variables. आज हमारे इस कोर्स का 15वां लेक्चर था, and today we have completed the discussion of the first part of this course, and that is descriptive statistics. In all these lectures that we have had during the past weeks, you have noted that we have learnt different ways of describing that data that you have collected on sample basis. The next 15 lectures will be devoted to probability theory, the most important theory which will be the foundation for statistical inference. Until next time, my best wishes to you, and Allah Hafiz.